Was supposed to be hosting today's colloquium speaker, but he disappeared earlier this morning, so I've had to take over. So it's my pleasure to introduce today's colloquium speaker, Todd Guerin. Todd's currently a third-year student in our very own physics department. He spends most of his time working in high-energy phenomenology. However, today he's here to tell us about the fundamental interpretation of quantum mechanics. Please join me in welcoming our speaker, Todd Guerin.
Hello? Can you hear me? Yeah? We're good? Great. So, hello, welcome for coming. I'm here to tell you, as Dan lovingly introduced me, I'm here to tell you today about some work I've been doing with my fellow third years on the interpretation of quantum mechanics. So, as you can read, this talk's entitled Experimental Evidence for the Many Worlds Interpretation of Quantum Mechanics. So, I'm going to talk to you about something we've decided to call the Blotz mechanism. And we're going to use it to explore the many worlds hypothesis. We're going to ultimately confirm it. We have some experimental slides, but thankfully, since I'm a theorist or a phenomenologist, we're going to skip those. We're also going to skip this slide. So in the Copenhagen interpretation of quantum mechanics, the one we usually know and love, we say that when we measure a wave function, it collapses. Great. But in the many worlds interpretation, we say, hey, we just happen to live in a universe where we would have always gotten that same measurement. But what if we can travel between these different universes? Good question. Now, this is what the Blotz mechanism allows us to do. As you can read, it's hideously complex. It's more complex than we want to talk about for the time being. So instead, in a couple minutes, I'm going to show you a video of my colleague, Joey Suttle, another third-year grad student, crossing over into another universe. It starts with some footage of him in a lab, but it's fine. So before we actually show you this footage, I want to take a couple minutes to introduce the few, the proud, all 8 of us, the third-year graduate student cohort. So can we get a round of applause? All right.
Hey Lauren.
Yeah?
Have you seen Bob?
No, I haven't. Why?
We just heard him for a Colloquium. I can't find him anywhere.
You want me to come help you?
Yeah, that'd be great. Jason. Jason, are you in there?
Yeah, what's up?
Have you seen Bob?
No, I've been in here all morning.
All right.
Have you guys seen Bob anywhere?
You mean Spot?
No, I mean Bob. Have you seen him anywhere?
No.
Ding-a-ling, ding-a-ling.
Yo,
Hi, Tom. Hi, Aaron.
Todd. How's it going?
So, we're having some problems in Chamberlain, and we need your help. Have you seen Bob?
Have you seen Bob? Not in any events. You tried calling those notes? Not yet. I'll get to it.
Thanks anyway. See you soon.
Mr. Smith. Yeah. Could have seen it though.
Yuri, what are you up up to?
Green left. What do you want?
Well, have you seen Joint?
Sorry, I don't smoke. Check the Grand Lounge.
Thanks for your help.
See ya.
Alright, Bob, why don't you take a seat? You're in another universe right now. It's okay, though. It's gonna be kind of like normal life. You'll just be doing a few calculations. See, if you try to leave this office and explain what's happened to you, nobody's gonna believe you, because you're already a copy of another Bob in this universe. So, I think it'd just be best if you do what I say and start working on these integrals that I've laid out for you. That'd be great. Thanks.
Guys, we looked everywhere. Where's Bob?
I don't know. We can't find him. We had Tom and Aaron come back from CERN to find him.
Yeah, I don't know why that was really necessary.
Colloquium?
Guys, how about this idea? Let's not have colloquium, let's take the pizza, let's take the beer, and just go home.
Did somebody say Holmes?
No. Who are you?
I'm Sherlock Holmes. What's physics detective?
Did somebody say Watson?
What's on?
Who are you?
I'm physics detective.
Well, do you want to solve a mystery for us?
What's the mystery?
So our department chair, Robert Joint, has gone missing.
These pictures of them.
So do you want to take this case? Yeah? Are you doing anything this afternoon? Okay, sounds good.
Yeah, we'll take the case.
Great.
Hello again. Could I have Professors Wachowski, Erickson, and Safman to come on down? We're going to make them do a little skit. They haven't seen the script before. So, let's give them a round of applause. So, let's get going.
Applicant one. Hopefully you can find some good applicants today. We really need to fill this faculty position. Sure hope so. I'm Mark.
And you're also Mark, and you're also Mark.
Your advisor's name is Mark?
Yes.
Oh, all right. So, can you explain your research?
I've worked mainly with Rydberg atoms and quantum information.
Sounds good. What did you say your name was again?
Rutherford.
Thanks for taking the time to stop by. We'll let you know if we make any decisions.
Thanks.
Sounded okay. His research was pretty interesting. Did you hear his name, though? Oh, applicant
Colloquium 2, please come in. Hi, I'm Mark.
I'm Mark.
Hi, I'm Mark. So tell us about your graduate work.
Well, I don't have a PhD per se. I've done a lot of physics research on my own in hidden variables, multi-universes, magnetic monopoles, that sort of thing.
So, do you have much teaching experience?
Yeah, I'm glad you asked. I taught my dog how to sit, and he can catch the frisbee pretty well.
I don't think we caught your name. What was it?
Mark.
Oh.
I mean, thanks for stopping by, Mark. It sounds great. We'll be in touch.
All right, thanks a lot.
You might be the man we're looking for.
I like this guy.
I did too, but there's one more applicant. We better hear him out.
Hi there.
Mark.
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 I'm Mark. Well, let me see. Looking at your application here. Your name is Brendan, is it?
Yes, that's correct.
It's been great meeting you, Brendan.
Okay.
Well then, I guess it's settled. It's clear. We're clear we really only have one qualified candidate.
Absolutely. I thought Mark was just the guy.
No competition.
Can we get another big round of applause for Mark, Mark, and Mark? And another for our new Professor Mark as well.
She's likely quite brilliant. The worst is she sniffs her hair. I can't explain it. I'll find out. Yeah. The hair's I wear her hair a lot. Really weird. No idea what
All right, if Gary needed a kidney, and if I were an eligible donor, I probably won't be.
It is a very tough class, and the professors really don't help. Electromagnetivity is awful.
This guy is an excellent teacher, far and away the best prof in the physics department. And he's also like 25 feet.
Professor, I've had him a lot. Not if there's any choice of profs, but his child was pretty good. I still don't like physics, but at least I had a better time hating it.
Do you guys ever wonder, like, what's the deal with photons, huh? You know, like, are they particles or are they waves? Make up your mind, Einstein.
Hey, Josh.
Oh, hey, Nick.
What are you looking at?
Just some work stuff.
Oh, yeah?
So how's holiday colloquium stuff going?
Oh, not too bad. It's coming along, you know.
You guys, like, any ideas, or? Because I got some suggestions.
You know, I mean, I think, you know, we've got it handled now, but I'll let you know in the future if we need any help.
Okay, because if you need anything, just let me know.
Yeah, no, thanks for the offer. I'll keep that in mind. There we go. Should probably get some work done. Check if I got any emails here. Wow, it's a lot of emails. Yeah, what's this power?
Right, so it's a very special episode of Baja Valentican's Mustache Show. Right, so we all have a lot of fun, but we also learn a very important lesson.
What is this? Hey Denise, I think there's a leak in one of those wage lock joints.
So, speaking of joints, think Dateline meets America's Next Top Model. On point with Bob Joint. Where's that?
Hi, I'd like to place an order for a triple order of topper sticks for delivery. Yeah, Chamberlain? Alright, thanks.
Hey, I got a delivery for Nick Brewer, and I got some sweet colloquium ideas.
So how's the colloquium stuff going?
It's going pretty well, but Josh is kind of being obnoxious.
Who's going to show off and we're going to show them the ideas, right, Nick?
So then electrons have mass? I didn't even know they were Catholic.
Right, so then the mask comes off, and it's Lisa Everett the whole time.
Oh, hey, how's it going?
Oh, hey. Not too bad.
Yeah, what's you working on?
Just some work stuff, yeah.
Oh, not Colloquium? I thought maybe you'd be working on Colloquium.
You know, it's kind of been a long day, and I just, I think I'm not even going to worry about it tonight.
Oh, really? Because I thought we were going to tape tonight.
No, I think maybe we can just do it tonight.
Oh, because I've really been practicing my Mark Wachowski impression. I think it's getting pretty good.
Wait a second.
So we can edit everything we're supposed to put together.
Hello, everybody. We have a very special competition for you this afternoon, Iron Chef Chamberlain. In this competition, our chefs will be working with a secret ingredient to make a meal and a dessert. So let's bring out our challenger. Let's give a warm welcome to Daniel Crow. So Danny, you get to pick between our 3 Iron Chefs. Your first choice is Iron Chef Solid State, Joey Subtle, who specializes in Italian food and baking silicon wafers. Your second choice is Iron Chef Fino, Todd Guerin, who specializes in Latin American cuisine and strange particles. And your third choice is Iron Chef Plasma, Jason Milhone, who's from Wisconsin and specializes in cheese curds. Which of these 3 Iron Chefs would you like to face off against?
Well, before we begin, I just have one clarifying question. Is there a time limit on this?
Yes, there's a strict 1-hour time limit.
In that case, I'll choose Iron Chef Plasma.
All right, let's bring him out here. Iron Chef Plasma, Jason Milhone. Give a warm welcome. So you will have 1 hour to make a dish and a dessert with our secret ingredient. And today's secret ingredient is the Chamberlain vending machines and anything else you can manage to scavenge from your offices. Your time starts now.
Having trouble sleeping at work? Is the stress of grad school interfering with your nap habits? You just can't find a comfortable position? Thinking about just giving up and going back to work? If you suffer from the chronic, debilitating condition known as nap insomnia, there's hope with Colloquium. Just a weekly dose of this non-habit-forming sleep aid will send you into a peaceful slumber for at least 1 hour or however long the speaker continues talking. Side effects may include confusion, anger, drool stains, physical injuries, and embarrassment. Take control of your life and get your nap time back with Colloquium.
And we're back from commercial break with the conclusion of Iron Chef Chamberlain. Let's bring out our challenger and our Iron Chef. and they'll tell us about what they made. We're also going to bring out our judges, Brendan and Sophia, who came all the way from England to just judge this competition. All right, so let's get started with you, Challenger. What did you prepare for us this evening?
Oh, well, I wanted to start with the basics, so I went with nachos. I started with a bag of Doritos, nacho cheese flavor, of course. But instead of a traditional cheese sauce, I went with something a little more exotic, mole, which I made starting from some seasoning from some barbecue potato chips, some nuts from a mixed snack bag, and of course no mole is complete without a little bit of chocolate, so I used some crumbled up M&Ms and a Snickers bar.
That sounds very tasty and very nutritious. Iron Chef?
I really wanted to step outside my comfort zone tonight, and I think I'm truly pleased with the result, pad thai. Started with some noodles from my office mate's ramen. Sorry, Joe, if you're in here somewhere. And added a slightly sweet peanut sauce, made of the inside of Butterfinger and Reese's peanut butter cups. And then I simmered it down in a thick broth of Chamberlain drinking water with the onion flavor of sour cream and onion chips. And then did a nice garnish of lime fruit snacks and crushed up peanuts. Served with a dusty black coffee. Bon appetit.
Yeah, I've heard that Chamberlain drinking water is very good for you with all the mineral content. And what did you make for dessert, Iron Chef?
I started with some chocolate milk, went up to the third floor and made a nice seasonal treat, used liquid nitrogen to make some ice cream, added some crushed up Kit Kat for a little bit of crunch, and then I sandwiched between 2 chocolate chip cookies and dipped that in melted chocolate for a nice crisp coating.
It has been very hot outside, so the ice cream is appreciated. What about you, Challenger?
I've also been feeling the heat wave, so I decided to go for a smoothie that I made from the scooped out insides of a strawberry Pop-Tart, some blue Powerade, and some Skittles. But I wasn't sure if that was enough, so I also had some broken up pieces of Rice Krispie treats that I coated with a melted Lifesaver syrup.
Yeah, I'm sure that wouldn't get stuck in your teeth at all.
Maybe just a bit.
Judges, what do you think?
Well, that's a tough one, Chairman. The challenger's use of the flavor of all kinds of different chips was really innovative. And the spicy chocolate mole really brought me back to the times as a grad student in Mexico City. Really authentic, really tasty.
Yeah, but the idea to steal the ramen from your office mate's desk really showed why our Iron Chef was crowned as such. Probably wasn't the cooking. And to use everything chocolate from the vending machine was wonderful. Just wonderful. I think the only way to determine the difference between our two contestants is just one real question, as my colleague will explain.
Yeah, that's right. Which one is cheaper?
So, our Iron Chef spent $3.75 in the vending machines and committed larceny, while the Challenger spent only $2.50. I think it's clear who our winner is. We have a new Iron Chef!
Gee, Yuri, what do you want to do tonight?
Same thing we do every night, Nick. Try to take over the world. One day I was thinking, why are people trying so hard to build a quantum computer? Well, why don't we just start with something simpler? And that single idea led to something awesome. The core of the theory is quite simple, really. Who says h bar has to be so ridiculously small? Why don't we just change the value of h bar? I mean, it's not like a universal constant or anything. So we did that. Me and my colleagues in theory said h bar to 1 all the time. Why don't we just set it to million, 10 million? think of the possibilities that we can reach with that. I developed a theory doing this, and once I was done with that, I needed to start experiments. But I'm not good with that, so I went to my buddy Nick.
So my buddy Yuri came up to me and said, Nick, I have a great idea. You know, the quantum computer thing, those are pretty complex, right? Why don't we try to quantize something more simple? So right when we started working on this, we kind of did our own thing.
Every once in a while, we step on each other's toes. Nick tried to help me with math, but his practices were certainly so I kind of tried to get him out of my office every once in a while.
I helped Yuri out with the math. But, you know, I just didn't, Yuri's just not an experimentalist, I'll put it that way. He was kind of rough on the equipment. I'm not sure why, but I had to clean off the optics pretty much daily.
Right? And then so we like break it down. It's like physics, physics.
We started with this one step at a time, or I guess, well, 2 steps at a time. What we did is take a small plank and quantize it into steps.
So we started out with something small, right? We didn't want to jump in over our heads right away. So we started out, we got a little ramp. We turned it in a couple steps. Yuri, can you come out? Yes. Genius, right? I know, but that's only the beginning.
After we figured out the 2-level system, we went on to create ladder operators to create an entire staircase of levels. One of the problems that we did have with the staircase, though, is the 0-point energy. We could never get off of the last step. That posed some problems.
The next thing we did was emulate an atomic process, EIT. So the best way we found to do this was with juggling. So we found our friend Jared, who's both an atomic physicist and a carny. After only a small amount of time, we were able to perfect what we now call EIT juggling.
Can you hear me? No. Can you hear me? Yeah. Lovely. So, welcome to the future of computation. Brought to you by Wolfram Research. I am Stephen P. Wolfram, author of the international bestseller, A New Kind of Science. I'd like to share with you something I've been working on. Something breathtaking. Something stupendous. With the help of the UW Madison Physics Department, I'd like to show you something I've been working on called Mathematica X, optimized for physicists. The first thing you'll notice is throughout this presentation, I'm not going to touch my keyboard, yet things will type. This is because of our favorite new feature, telepathy. We're sure you're going to love it. So let's start by talking about some features. Physicists, unlike mathematicians, don't always worry about doing their integrals safely. As such, we've introduced a new kind of integral, the P-integral, or pintegral as we've taken to calling it. So the P, of course, stands for physics. Let's take the integral of a function.
Mike is out.
My mic's out? Hold on, technical difficulties. I'll be back. Can you hear me if I yell? Yeah. Lovely. So, I'm thinking, start, integrate. So as you can see, it doesn't always correspond with what I'm thinking. This is only a beta. We hope it'll help. So, gross. Let's pentagrate. Brilliant. Let's integrate another function we all know and love. E to the minus I kx over 2 pi over k from minus infinity to infinity. Come on, I'm thinking. It doesn't converge, but let's pentagrate it. And you know, I should have just thought about copy and pasting. Too late. Sublime. So we've also taken liberties to introduce various other functions. For example, we've introduced a new kind of sum, the p-sum, or sum as I've taken to calling it, because some sums don't sum correctly. Let's sum. Doesn't converge, but we know it should converge, so let's sum. No, I'm serious. This sum converges. Wow. Just wow. So, since we've implemented telepathy, some things thought impossible are now possible. Let me show you one of my favorite features of Mathematica X. Something that'll just take your breath away. So grant proposals, something once terrible, are now easy. Let's think about the right grant function. This is from my new book, A Newer Kind of Science. So I'm Cellular Automata, and I want to write a cover letter to the NSF. So I'm thinking right now, and voila. It's a newer kind of NSF grant proposal. So, but that's not all though. Mathematica X is much more powerful than that. Let's think about a problem. Let's say if we're doing a problem 6, I am free to ask Mathematica things. So let's ask Mathematica about a condensed matter problem. I have one in my head, it knows, and it's going to tell me how to solve it. So let's wait. I'm asking, expand around the Fermi surface. Great. Let's say I'm thinking about a classical mechanics problem. I have one in my head, it's something about orbits, and it's going to tell me what I need to do next. Now, let's go to one of our favorite subjects, quantum mechanics, okay, guys? What is Mathematica going to tell me to do with this problem I have, sitting in my little pretty head? Brilliant. These are just some of the many features available in Mathematica 10. But, and one more thing. We're introducing Mathematica Mobile, available now on iOS and Android, so that you can never be without Mathematica. You can never be without something reading your mind. So, with that, thank you all very much.
Looks like this office has a high capacitance for clues.
Yeah, I think we should look around and see if there are any signs of resistance. Like, maybe this coffee cup.
What about it?
I don't think he would have left this here.
Why not?
Elementary particles. Years without coffee is basically useless.
How long ago do you think he was here?
Just a few hours.
Hey, look at that board.
Oh, this is strange. It looks almost like he's doing something to do with multiple universes, but that would be crazy.
Seems like the voltage in this case is really amping up.
I've got the world on a string, sitting on a ring.
Where's Bob Joint?
I think the real question is, when is Bob Joint?
You're string theorist.
That's right.
Is there a chance you could take Bob to another dimension?
No, I don't think so. I think they'd be too small. But he could be another you.
Hey, have you seen Bob at all today?
I saw him earlier this morning.
Do you have any idea where he could be now?
I saw him at Joey a while ago.
All right, let's see what we got here. No. You can't take these kind of approximations. This is just unacceptable. Look, what I need you to do is take the PE and resolve it to 7th order, okay? It's totally trivial. It'll be fine. Just, yeah, 7, exactly. That'll be good. If you get hungry, I wrote the number for QQ on the board. Just call them food or something. Anyways.
Okay, I've got a few questions for you.
Sure.
Have you seen Bob Joint today around Kittle?
No, I feel like I may have seen him last week or something, but it's been a while.
And have you noticed anything unusual or out of the ordinary?
Not really. Although, I feel like I may have had kind of a moment of deja vu earlier. But it was kind of strange. I could have sworn I saw somebody who looked just like me walking down the hall. It was very strange. I guess that's not really deja vu, but you know what I mean.
You say look just like you mean look kind of similar.
I mean, pretty dead on. It was kind of otherworldly.
Man, Danny, I was thinking about it. It seems like this holiday colloquium isn't very holiday themed so far.
No, but stay tuned for the second half, which starts in 10 minutes.